This is Trial Exam 2019, ST&SP paper question number 2. So we've got a diagram with an electric kettle and it's got a coil of wire in the bottom. The Sankey diagram shows the energy transfers that take place in 1 second when the kettle heats some water. So we remember that if it goes forward, that's useful. If it goes down, that is not useful. It's wasted energy. So what is the energy input per second? Well, if we add these two together, they're going to make what should have been the energy input. So in this case, we would tick, or we would put a cross in 2,500 joules. Very simple to start. There is a large insulated coil of wire inside the kettle. Explain why this coil of wire gets hot when the kettle is switched on. Right, notice they give you a clue. They've said, why does it get hot when it's switched on? So for 2 marks, we need an explanation. So we've got to give them a reason why. So we're going to say, because there is current in the wire, you can say a few things here. Because there's current in the wire, you can either say that it collides with the electron, the electrons collide with the ions in the coil, but we're looking for something like it transfers electrical energy to thermal energy. So I've been teaching people that current makes things hot. So why does it make things hot? Because it has a resistance in that wire. So as the current moves through, the resistance of the wire causes the resistance of the wire is the collisions of the electrons with the ions in the wire, and then as they collide, they've got a little bit of friction and they change some of their electrical energy into thermal energy, making it hot. The power of the kettle is 2.5 kilowatts. Remember that kilo equals times 1,000. Operating at a voltage of 230 volts. What is the power, current, and voltage equation? So we should just have P equals I times V. Show that the current in the kettle is about 11 amps. So we're going to rearrange for the current. And we're going to put this in, but we're going to times it by 1,000 because it's kilowatts. And then we put that in, and then we're going to find that comes out to be 10.9 amps, which is about 11. I get 2 marks. The plug of the kettle is fitted with a 13 amp fuse. This is going to be a describe question, how the fuse prevents the coil of wire from overheating. So we're looking, it's 3 marks, we're looking for 3 points. So we're going to say, in a logical order, the current, if the current goes above 13 amps, the fuse will melt, and that breaks the circuit, which stops it from overheating because we explained up here that there is no current in the wire, so it won't get hot anymore. And that is question number 2.